Hi, this is Billy from Vega Neutral, and welcome to our course on basic interest rate calculations. Today we will cover present and future values. This course will help you to understand how present values and future values relate to each other. Let's start with understanding time value of money. Now let's assume you're in a game show and you are fortunate enough to have won the prize and they're offering you one of these two doors. Behind door number 1 lies a prize of $1 million. You get the prize today. Door number 2 says you can receive 1.1 million, but in a year from now. How would you know which option to choose? You would need to know a few more things to make that decision, such as the likelihood of default. In other words, what's the chances of the entity or the person that's about to give you the $1 million at the end of this year still existing? So in other words, are they going to be able to pay you the $1 million in a year from now, or are you safer taking the money and holding onto it yourself? The second thing to consider is, what is the current money market deposit rate? So in other words, if you just go to the bank, put your money on deposit, how much interest are they going to pay you? This is also referred to in this example as a risk-free rate. The only other thing to consider is the compounding frequency. In this particular course, we won't cover compounding interest rates. For now, just understand that's the frequency with which the actual interest that you've earned up until that point is added to the principal amount invested. That'll be covered in a separate course, which I also recommend you view at a later stage. And the final thing to consider is, what is the current rate that we can earn on other investments that offer similar or lesser risk than the current one that we're about to take on. So let's look at two examples. Example 1 says, first and foremost, let's assume there is no risk of default. So in other words, we are certain that we will get our money back at the end of the year. The current market deposit rate, in other words, placing your money with a bank, pays 5%. And NACA stands for your interest being capitalized once a year at the end of the period of your investment. And let's further assume that the current rate that you can earn on other investments of similar or lesser risk is 8%. And here again, interest capitalized annually. Under these conditions, which door would offer us the best value? Door number 1, where we get $1 million today, or door number 2, where we get $1.1 million in a year from now? The answer is door number 2. Let's look at another example. Let's assume once again that there is no risk of default. But in this example, the current market deposit rate is 12%. And alternatively, the other investments with equal or lesser risk offers 20% return. Which door now would you choose? Door number 1. How did we know which option was the best in each one of those two scenarios? We only were able to do so by thoroughly understanding the relationship that exists between present values and future values. Let's have a look. What is meant by present values? It relates to the current economic value. In other words, what can you do with the money that you currently have in your hand? What is the purchasing power of that money? Another way of looking at it is the immediate utility value that it offers you now. In other words, you can walk out of the door now and have money in your pocket to go and buy stuff with right now. So let's see what you can do with money in your hands today. You can spend it. You can put it in the bank to earn interest. If you want to, you can lend it to somebody else and earn even more interest on your money. Or you could go and invest your money in the stock market. So in summary, by having funds in your pocket today, you can account for various ways in which you can put it to use. So back to our game show example. What if I give you your money a year from now? Now in this instance, waiting for your cash, you can't spend it because you don't have anything. There is nothing to put in the bank, so no interest that you earn. Also, you couldn't lend the money to anybody else even if you wanted to, because again, you don't have any money. And lastly, you can't go and buy shares. So you have to account for the fact, what happens if the shares that you were going to buy is anticipated to grow quite a bit, and the stock market goes up and you lose out on the possible return there. So how do we account for this? In essence, we want to equate present value and future values to some sort of rate where we can say, what will create a situation where we are completely indifferent to receiving the money now, or alternatively, receiving some future value in a year from now, as an example. So what is the real question that we are alluding to? And that is, what is the price of money? In essence, what we are saying, in money terms, the price of money is called an interest rate. Now, as I've explained to you in the beginning already, an interest rate has to account for a few things. It has to account for the risk-free rate. In other words, what can you get at a normal bank or a normal investment that carries very little risk? It also has to adjust for inflation, because if inflation is 4% and your investment yields 4% per year, you're not going anywhere. There's no growth in your investment. And then lastly, as I pointed out earlier, it has to account for risk. Now, risk in this instance can be more than one thing. It could be physically the risk of default, or alternatively the risk of an opportunity lost. In other words, you could have invested your money elsewhere, but yet you turned your money over to this investment and tied it into this investment for the year. The summary here is that with enough interest, we can actually find ourselves in a situation where you are completely indifferent to getting your money now or at some future date in time. Using this example, I've used an arbitrary amount of 10% interest per annum, and I'm saying getting $100 today versus getting $100 plus 10% interest in the future is a situation where you are completely indifferent to either one of the two. So how do we calculate the future value? Very simply, we take today's amount plus the interest that we will earn, and we adjust it for the amount of time that the interest itself capitalizes to the investment. So $100 today invested at 10% annual interest will mature to be equal to $110 a year from now. Now, once again, this example only assumes interest is capitalized once a year only. In our course about compounding interest, you'll see how dramatically this amount changes with the effect of interest capitalizing more frequently. Here's a look at the formula for calculating the future value. It's the present value plus the present value times the interest. So if you want to equate it a little bit differently, you can also state it as the present value times 1 plus the interest that you're going to earn. So let's look at the real example. $100 plus 100 times 0.1 equals 110. Or alternatively, 100 times 1.1 also equals 110. Now I have to remind you, even though interest is written out as 10%, when we do equations, we use it in decimal format. In other words, 10 units out of 100 units, 10 divided by 100 equals 0.1. And that is the number that you'll use when you do interest rate calculation. Again, this example assumes interest is capitalized once a year at the end of the period again. So in summary, if we are comfortable that the interest we will receive compensates for all the risks as well as the opportunity cost of not being able to invest elsewhere, then we can in fact create a situation where we are completely indifferent to getting our money today or a year from now, as long as it's adjusted for the price of money, the time value aspect of money. So here's the reminder. To get a future value, we take today's funds and add interest to it to get a maturing value of 110 a year from now. The formula is the present value times 1 plus the interest rate. We could also start on the other end and said, what if I was going to receive $110 a year from now? And what amount today equates for an equal value? So in this instance, we'll take 110 less the effect of what the interest would have earned over the period. And that'll bring us back to $100 today. The formula looks like this. Future value divided by 1 plus the interest rate. So in summary, the relationship between future value and present values are tied together with regards to the interest rate used for that specific period. So what I mean by that, if we are dealing with an interest rate of 10% and the frequency of compounding is once a year, there will only be one value to which an investment of $100 can grow to at the end of 12 months. And similarly, if we look at a 12-month investment with interest capitalized once during that period, and we say we have a future value of 110, there is only one answer of what the present value would be, and in this instance, it's $100. Let's just see if the sums work. We've already calculated the future value starting off with a present amount of $100. Let's do it the other way around. Let's say, what is the present value currently of an amount of $110 coming our way at the end of a year? And we know the formula is future value divided by 1 plus the interest rate. And in our example, you can see $110 divided by 1.1 brings us back to $100. So let's review our game show examples. How did we get to the answer of which door to choose in each one of the respective examples? We knew that door number 1 gave us $1 million today. We also knew that door number 2 gave us 1.1 million, but in a year from then. So moving from a present value to a future value, it's the amount today plus the interest rate, or alternatively, the formula as expressed there. Or alternatively, we can start on the other end and said, what is the 1.1 million worth in today's money, given the interest rate? And we can say 1.1 less interest gives us today's value, or use the present value formula. So in this example, we had all the variables to make the equation work except one. What interest rate is implied in all these calculations? And when running the numbers either direction, so in other words, starting at either the present value working out the future value, or starting with the future value working out the present value, the implied interest that we'll earn is 10%. And once we knew what the implied interest rate was, we can compare it to the two options available. So, example number 1 said, current market deposit rates were 5%. The current rate earned on the alternative investments were 8%. So in those cases, all those rates were lower than 10%. So for us, it makes more sense leaving the money with the game show host and only get our funds a year from now, as this investment earns physically more than anything else available. So in this case, we chose door number 2. In example number 2, the current market deposit rate was already 12%, and the current rate earned on the alternative investments was 20%. So in that instance, with both the other alternatives earning much more than our implied 10%, we'll be better served taking the money today and investing it ourselves in one of the other two investments that's out there. So in that instance, we chose door number 1. I hope this course helped you to understand how present values and future values relate to each other. This is Billy from Vega Neutral, and I hope to speak to you soon. Bye-bye.